Hi there, this is Ayush from Lightscline, and today we are going to talk about Lightscline visualization tool. Now, this is specifically useful if you want to go through a lot of data. You might have distributed acoustic sensing data or any kind of sensor data, which for which you have and the data is like 2 months worth of data, a couple of weeks of data, or something like that. It's a large amount of data relative to time, and you want to see what's happening in the data. What's happening is there, and you want to find out what are the anomalies which are happening in the data. So the visualization tool is designed to manually look through the data, and then you can go to a rabbit hole. That's the goal of it. This is also helpful in cases where you know what you want to find, but you kind of want to see a lot of it. So, for example, in the microseismic use case, you know what microseismic signature is going to look like. You know what kind of processing is required to see it, but you kind of want to see, like, manually look at, let's say, 100 events or 500 events or something like that, so that you have an intuition of what kind of noise levels are we expecting and stuff like that. So the concept is pretty simple. You have data which is sitting on site, because I'm expecting you could have like terabytes of data, and all of that and you have like a generation UI which generates a lot of images. It's multi-threaded and all of that stuff. This is going to sit on site and it's going to generate a lot of images. These images can be transferred to cloud or can remain on site, and we are going to use like a dashboard which again can be offsite on site to view at these images. So this is the basic, pretty simple concept. You generate a lot of images from the data and then you look at them. uh, the good thing about it is, like, you can leave this generation part uh, running overnight, or if you go for lunch or something, and then once you come back you can look at the images. Thus it kind of saves your time. Now I'll quickly go through the generation tool, because this is very straightforward. You kind of have like data source setup, you tell it where the data directory is and stuff like that. You have multiple readers, how to read your data, like you have HDF5, TDMS, those kind of readers which are built in. You can also have custom reader, which you can write. For example, if you have .raw files, uh, you might want to write your custom reader, but that's an example, obviously. Now you might want to, for example, do some kind of bandpass, let's say 10 to 80 hertz or something like that, and it's going to do that. You might want to specify how long each image is going to be. So for example, in microseismic, like, if you look at, you might want to look at 5-second images, but if you're looking at some kind of ocean phenomena which happen over a long period of time, you might look at like minutes, like 4 minutes of images. So this is an example uh, of a subsea cable, and the goal here is, like, can we find something interesting? So I can, one of the, in the subsea cables or in the marine world, or in general, you look at FK domains very specifically, because here you can clearly see ocean surface waves which are defined here, and then ah it's pretty straight. I mean, yeah, but basically now I can see how this ocean surface wave signature change over time by using my arrow keys. So I'm pressing my right arrow key, and if you see, these numbers are changing and the images are changing. Now these images are pretty similar, so it's very hard to see what's happening now. But right now I have only chosen like first 500 channels. You can also choose, I can also go further from the shore, so I can choose channels which are, let's say, 500 to 1000 channels, and see what's happening to the ocean waves. So if you see here, uh, the ocean surface waves tends to get smaller. So, and at some point like if you see at some point they vanish and you are only able to see short waves. So if it's too far away from the coast, you're only able to see short waves. This is interesting, but the more interesting part was, what are these? These are neither ocean surface waves nor short waves. And you can kind of investigate this further. That's the whole idea. But what you can do here is now, I added another panel because I want to see, let's say, I want to see FFT of the same channel range and of the same time. So yeah, I'm able to see there's a bump in FFT here, but more than FFT, I kind of want to see the time domain signature, as in what happens. So if you see here, it's pretty obvious that there is some energy increase above channel 3700 or something like that. And below that, you're kind of seeing like uh, some kind of slant waves, which are probably ocean surface waves. And I can see over time how it changes. And you see that as these signatures, like as these blobs of energy decrease, you're able to see those ocean surface waves, the signature of those better, and these intensity goes down. So this kind of means that whatever signatures you're seeing here is very correlated to these channels specifically. This gives us some clue, but now what else you can do is, now you might not be looking for this signature, so you can just char it. So if you see here, there's a star here. I just charred it, and then I can go back to this charred label and then see all the images that I have charred. I can also create custom labels. For example, this is a short wave, so I can actually create a custom label for short wave and then classify it as short. And if I see something impulsive, I can, for example, classify it as impulsive. But you can create like custom labels and give it its own name and stuff like that. We have a help button if you ever forget shortcuts for everything. And for example, if I want to add a custom label, I can just create like a label name and it kind of add that. So this is basics. You're able to see a lot of images, you're able to label them. For further analysis, you're able to star them and stuff like that. But you can also do clustering, which is like, because you have generated a lot of those images or all of those images, what you can do is, let's say I want to cluster all the images in the FK domain and I want to cluster it for specific, either I can cluster it for all the channels or I can cluster it for a specific channel group. So for example, 4500 to 5000 or something like this channel group, and then I can just run this. What it does is it takes all the images and clusters it, as in like, basically if two images are similar, you'll see all the short wave images in one cluster and all the anomalies in another cluster. This makes it much easier to look through the data if you have a lot of it. But again, depends on how much data you have, how much images you generate. So that's it for the product demo. Now, again, I want to leave you on the high note. Why we are doing this is basically why we are doing a lot of these processes, so that you can actually manually go through a lot of data, and it's not very cumbersome to actually do that. It's very easy. You can do it in, like, for example, we were able to analyze like 14 days of dash data within like 2 hours using this methodology. And the cable was, there were two cables, so one cable was like 1 kilometer, another cable was like 50 kilometers, and all of that within 2 hours we were able to see what are the anomalies and stuff like that. Again, your research doesn't end here, it actually starts here. uh, Once you find an anomaly, you kind of have to write your own code to figure out why the anomaly was there in the first place and stuff like that. But this makes at least looking through the data part very, very easy. So that's it from my side. If you have any questions, just email me at ayush@lightscline.com. Thank you.